Okay, we're with Petestep, Petestep AB, Petestep company. Petestep is a significant step in developing hulls for planing boats. We can provide a much softer ride. We can create a lot of more side stability, and we can still drive the boats lean or even leaner. Petestep is for users, people doing rescue services in planing hull boats, people doing operations in planing hull boats, people using leisure planing hull boats. We will make a difference for all of you. But Petestep is not something that we developed to develop boats ourselves and sell. Petestep is something that we have developed to work in cooperation with boat builders, producers, boat brands. So we're here for you guys. Build boats with our bottoms, and we hope that we can make them even better for your customers. We're also here for naval architects that would like to have an extra tool in their toolkit to provide a much better, hopefully, hull than ever before. And this is us. This is Jonas Danielsson, CTO of the company, and I'm Håkan Lindström, CEO of the company. And this is the whole company, by the way. We spent 20 man years of research and development. We have a patent on our hull technology. We spent about 3 million euros on the way out of our own pockets. We have a test and demo center in Stockholm where we can provide test rides with present hulls and future hulls and compare it with your own boats. We have 4 pilot projects, and here's our presentation. We can pass around the model as well.
Yeah, I'm going to pass it around so you can have a look.
It's slightly damaged after a rough ride yesterday at sea. So how do I switch picture? Like this? Conventional technology of planing hulls or hulls provides spray lists like the one that the Sea Rescue Service took away. Spray lists are there to take away wetted surface and reduce the friction at sea. Spray is a huge thing. This princess is probably throwing about 300 liters a second to the sides, just waste of energy. There's a lot of energy in that spray, and this is what our inventor Peter Bjersten discovered when he was racing boats. He was totally annoyed with the spray on the sides. He's constantly looking at it, wondering why it wasn't regenerated for forward thrust or lift or something more valuable than just waste. Previous research has been concentrating around reducing the spray around the stagnation line. You're all familiar with Savitsky and probably use them for your calculations. His models. This is not my home grounds, but we've been working outside of that with the whisker spray to understand what the whisker spray really is in potential for development of planing hulls ride. How can I ride this? This is just a ride to demonstrate a lot of wetted surface and a lot of spray to the sides. This is just another ride to demonstrate a boat with a very nice trim angle across the water, what you would like to achieve, just to remind you what we're looking at. Can we ride that one as well? This is the kind of ride you would like to have, but hey, you don't want to go that hard, do you? So this Pantera is probably causing the people aboard a hard time with all the bouncing, but look at the trim angle. That's the kind of ride you would like to achieve with your boats. Okay, sorry, should be in the camera.
We just hope they had Solomon seats.
This is one of our boats. This is actually our standard boat. We built 4 24-footers, kept one as a reference object, this one, and altered 3 of the others to develop our deflectors, understand what happened when we did different changes on deflector heights, angles, etc. This is just a ride. Sorry. Can we ride that boat? This is just a ride demonstrating a bit of spray, a meter and a half from the stern. The spray onto the sides is just pure energy waste. Well, look at this with one of our prototypes. Same kind of a ride, same engine, same point of gravity, slightly slower speed. Everything is underneath and behind the boat, creating a bit of a lift and creating a bit of a forward thrust, stabilizing the boat, no spray on the sides. The upper part of the picture is an ordinary boat with spray lists. The red part illustrating the spray that will not be reduced by or taken away by the spray lists, but still work as a wetted surface. The energy going wasted to the sides by the spray list. The lower picture is an illustration of a Petestep hull with swept deflectors from the keel line in taking care of the pressurized area and getting the spray from outside of the stagnation line, hitting the deflectors, creating a bit of a lift and a bit of a forward thrust, side stability, meaning you can ride softer, you can ride leaner, and you can ride with more side stability. Before we switch that picture, when that boat hits the water and goes into a wave, the wetted surface or the pressurized area divides forward and sidewards, still creating spray that goes downwards and backwards to help the boat suspend and re-energize the energy from the spray for lift and forward thrust. It works, just works. This is underneath our the model that you have now, the Huck 33P, a boat that will be launched within a month or month and a half or so. Deflectors starting from forward in the boat.
A laser picker.
Sorry?
You have a laser.
Okay. The deflectors start in the front of the boat and are swept towards the chines. The sweeping area is calculated by the program that Jonas has developed for simulation and calculation, and is individually adjusted for every hull constructed or every hull designed for a specific purpose. In this case, the inner deflector, where was that again? This one. The inner deflector will operate in speeds in 40 knots plus in this boat. The next deflector will operate in speeds 27 plus, and the outer deflector will just help and assist a bit. Creates a totally different ride. Okay, let's ride the boat that you've seen, the rough prototype outside from a Yamarin 81 DC. This is a ride where the boat starts at 37 knots and then goes up to 45 knots. And you can see as the water disappears inside the boat around 39 knots. And then it looks like the boat goes very, very high in the water. This is actually lack of spray and only about a centimeter or two in height difference from normal hull. Totally side stability, side stable, very, very soft ride. Of course, there is no wake or no sea in this picture, in this film, but still have a look. Oof. This is where the boat goes into the last deflector. This boat replaces a 79 DC, 300 kilos lighter than the previous boats, same engine. They ride similar speeds, similar fuel consumption. We always measure Gforces in every ride that we do, and this boat has, on an average, 57% lower Gforces in all kinds of waves and wakes.
That's impacts and peaks. That's the difference.
That's what we need a CTO for. Let's ride our prototype that we halved in size, halved in height, halved reduced in weight, and which have been competing. This boat, or a follower to this boat, has been competing last summer in Sweden with great results every time it came ashore with a non-broken engine. It's boat racing. The boat just suspends in the very back of the boat, never loses the trim angle, even when it goes through big waves, like right now. Just keeps suspending. This is not an aerodynamic thing, this is a hydrodynamic thing. This is these are the waves in 13 meters per 12 to 30 meters per second on Lilla Värtan in Stockholm. That's 24 knots of wind close to land. The boat never loses the side stability, never loses the bow to leeward. I don't know what that is in English. So the not wind side, the leeward side, and it doesn't lean into the wind. And this is just a picture from a boat coming out of a wake. You can see the water deflected from the deflector downwards and backwards. It's one of the early prototypes. Well, this is an interesting picture. Let's say this is a 23-degree dead rise. The conventional boat will have side stability as a 23-degree dead rise. It will consume fuel as a 23-degree dead rise, run fast as a 23-degree dead rise, keeping the same engine size, weight, etc. The Petestep hull with 23 degree angles on the running planes, I don't know if it's dead rise or anyhow, 23 degrees on these panels. This boat will be side stable as 19 degrees, consume energy or gas as 19 degrees, and have a softness as if it had a 29 degree dead rise. It's just a huge difference. It's all because of the way we treat the spray and how we can suspend the water and how we can direct it downwards and backwards. Jonas, what was this slamming thing? The red one is the standard boat on the project that we had, and the other one, and the blue one is prototype boats. And the Gforces were just totally much lower on the prototype boat throughout the whole planing speed range.
This test is a one-to-one test with a reference boat, same weight and everything. And we measured the impact peaks. So that's what you see here in the different speeds. So with our prototype, you can keep the same speed. You can keep full speed in the same conditions as the standard boat can only keep between 30 and 40 knots here. So that's quite significant.
Well, here's just a slide from last summer's racing. Someone got surpassed by the 150 horsepower Petestep boat. Let's just see the ride. It's over on the left-hand side. Somebody's GoPro camera. We're not boat races, but this was fun to watch. Okay. Well, here's an interesting thing for anyone evaluating the design of a new boat. This is an indication from the project with Yamarin, where we rebuilt their 63 BR. It's a 630-meter long boat. We built in their molds prototype with everything kept the same weight, center of gravity, same kind of engine. Rode the boats parallel and gave an index 1 to the standard boat for consumption, and a standard and an index 1 for vertical accelerations. And running alongside the standard boat would be this spot, and the prototype boat will be on this spot. 5% leaner, 30% softer. Coming out into the Finnish Bay with those two boats was fantastic. Me and Jonas riding the prototype boat, hearing this noise all the time. What do you think this is? That was a noise from the other boats 150 meters away, the spray lists. Our boat goes shh, 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 and the standard boat. And those of you that have ridden our rough test boat from the Yamarin project, 81 project, have also been able to notice how it's silent. It sort of bounces on the water more than slams. It's a short, fairly short suspended bounce thing going over small waves or bigger waves. You get into a better rhythm. It's easy to keep a trim angle. It's easy to ride the boat in bigger and bigger waves with a kept trim angle and no slamming. Okay, do I do this? That way. There you go. Okay, these are Jonas tools. You will tell. Maybe you can tell.
Yeah, so we've done a lot of one-to-one tests and measured all the G-forces, all the fuel consumption, speed, everything, trim angle, stability, and we put that into our simulation software and continually updating that. So now we have really advanced and accurate simulation tools. So we think we can do up to around 12 meters, 12-meter boats, depending on weight and speed, and it will be a really significant difference with leaner consumption, softer ride, no noise, better stability.
We did prototype with Yamarin. Okay, we'll hurry up. We did prototype with Yamarin in the process of making boats with them. But the prototyping always came to the same results that Jonas calculated in the software. So it's a very, very accurate software now. Yep. This is the launch boat. The Yamarino 81 DC was launched in Düsseldorf. It weighs 2.5 tons, 300 horsepower, dead rise 19.5, fuel consumption and side stability like 17 degrees, soft dry like a 27 degree. This is the Hawk 33 being launched in a while. It's a project that I financed to have an industrial project with Petestep from A to Z. It's 4 tons. We've driven it already. D6 400 from Volvo Penta. Dead rise 23, fuel consumption like a 20, side stability like a 20, softness like a 30 degree. We took it in 25 knots of wind from Visby to Stockholm in 17th of December in winter darkness, 28 knots on an average in the ride. Totally alone on the Baltic Sea. Sea rescue service was nowhere. We didn't need them, fortunately. We're building with Swedeship on an aluminum one-off, 10 meters, double Yanmars. Fantastic, interesting project. Will be launched within a month, and we're looking forward interestingly to test this boat as well. I don't have the date on that boat presented. Well, the summary from Petestep is we can ride softer, we can ride leaner, we can ride quieter, we can create a lot of side stability, which is perfect when you're going up to other boats to rescue or do operations, or just very much more comfortable. We have a better ability to tailor boat attitude. We say that the ride is a different riding culture, and you may experience that even in this 8-meter light boat, the white boat, which is on the water. Huge accuracy in our design process. When we make a design, we will not interfere with the DNA of the boats. As far as design, you can see the board Eke design of the 81 DC has nothing to do with us. We just do the hull bottom. And well, the boat is better maneuvering in any speed, but in low speed we found out also that the boats will go straight as you put the gas in forward, but also as long as you're in hull speed, instead of this common snaking procedure that we've all done in planing hulls, trying to get out and in of the harbor or do a canal. Well, that's Petestep. We hope that the rest of you that hasn't ridden with us yet will ride in our little 8-meter boat, try to understand what we're doing. We have business cards. Visit us on petestep.com. And if you're making a new boat with a planing hull, evaluate us. You may end up having a boat which is about 30% better in slamming, or 30% better in consumption, range, and the riding culture that would make your customers much happier.